Hello, good evening, everyone. I also have a surprise. I thought this surprise I will announce it in an hour's time, but actually the guest was able to make it from the beginning of this series. So with me, let me show him first. Okay. Oops, I don't know what happened there to the camera. There is Ozzy. I will need to fix the camera in a minute. Hello, School Coder. Hi. So basically, there is Ozzy. Ozzy, can you talk? Can you say hello to make sure that the sound is working?
Check. Can you hear me?
Okay. So with me there is Ozzy. He will be talking about Amiga demos and stuff like that, and what his things that he did. Hello, Dockster. Also, we'll talk about the tracks, let's say Game Jam, which I had the plan of starting tonight, but let's say there's a small change of plans. I will still start it. I will show you what I've done. But first, let me, you have to give me a few minutes to adjust the camera because somehow the screen where Ozzy is moved for some reason. I think we are okay. Let me see the other one. Yeah, we are okay. So, as always, I start with this part. Okay, so first of all, let me start with the usual stuff so that people can join. So basically, all I ask is for you to like my video, subscribe to my YouTube channel. This is how YouTube likes it. Just a reminder for those that forget, under each video there are the chapters and there are links to the sources related to what I share. And the chapters, you can select them from the bottom or from here. Okay, so that should be done. Of course, please follow us on our Facebook page and our Facebook group. Not this one. Sorry, this is nothing to do with today. This one, okay. Facebook group, Face 101, of course, or the other group that I have, which is Commodore Dev, where there are all the stuff related to Commodore, and I take the occasion to say hello to Walter and to Colin and thank them for their help with this Facebook group. Of course, if you want to get in touch with me, please go to Discord. I do see messages on Facebook, but I take longer, and normally I am more on Discord. So I have also Telegram if you want to get in touch with me direct. The community is growing on Telegram. I only started this a few weeks ago. Ozzy is a member of this. So you're more than welcome to join there. All the links are in the upper right hand corner anyway. If you want to support us, you can go to Patreon or Ko-fi. Both of them has got an identical amount of videos. If you unlock one of them, right now you can see that you will unlock 64, but actually there is more because I haven't approved them. They are just there, and I haven't said who should be able to view these or not. So yeah, that's basically it. So let's jump to our visual code. Okay, and we have, you can see that we have the Amiga here. I mean 68,000 code. This is Ozzy's code, okay, not my code. So the thing that we were going to do today was that I was supposed to do retro tracks, okay, and then Ozzy was supposed to join me an hour later on. However, Ozzy was able to make it today earlier, so I thought we start with him, given that he also was kind enough to do a presentation, which I will be sharing starting from page 1 of his presentation. So Ozzy, do you want to start presenting yourself and talking about yourself and say what you have done, etc.? Remember, you have to tell me when to change the page.
Yes, of course. Hello, everybody.
Give me a second. I think your volume is a bit low.
Do you want me to increase the volume?
No. I think your volume is very low. Can you talk now?
Check.
Yeah, now it's better.
I didn't touch anything.
Yeah, it's okay. It happens.
Okay. So, as I said, hello everyone. And first of all, I'd like to apologize for my terrible English. And I have a strong Italian accent, so please forgive me. I'll try to do my best. However, and then I want to thank Phase 101 for inviting me tonight. And what I'd like to talk about is a project that I have, and maybe possibly some talks about my experience and what I'm doing with Amiga programming. So first of all, I'd like to introduce myself a little bit. I'm Italian, Tuscany, near Florence, and I am an Amiga addict since 1993. That's when I got my first A600. And at the time I was a kid, I always dreamed about how to program this machine, because for me it was a wonder. But unfortunately, at that age, I was too young, no English, no internet, so it was very hard. And then happens that you forgot anything in the time. You use a regular PC, and then you came back to the Amiga because it was my first love. So I started, like probably most of the programmers here, I started reading the RAM Jam book, and it was fascinating for me. I learned a lot how the Amiga works, how the internal works, and because when you program on Amiga, you must have an intimate understanding of the
Can
hardware. It's not like a PC. You write the code once, and it probably runs everywhere with the same operating system, of course. And so the goal, after reading the book by Fabio Ciucci, was to try to do something. And I'm a demo addicted. I'm not into games. What I like is crack throws, intros, demos, also games, of course, but my main area of interest uh, is demos, and there are a lot of Amiga demos, very very nice. So of course I'm not able to do something even comparable to Nacolor or every other demo group in the scene. So where do I start? I started writing my own routines. Most of them are derived from Ramjam because, especially for the very basic one, for example, how to draw a line, how to draw a point, how to draw a polygon, a rectangle. So this is where I started. And very soon I realized that coding for Amiga is fun, but it's very hard because you are too prone of errors. If you forget something, you get a guru meditation, the system crashes, you have to reboot, and so on. And this is why I started thinking about unit testing. And this is my project. It's called AProcessing. It's named after another project that is called Processing that I use for prototyping. And this AProcessing is just my collection of routines wrapped around a framework, or let's say it's not a framework, it's just a collection of scripts that help you test how if they work and if they don't. So this is in a nutshell what AProcessing. Can you please turn the page, Phase? Just a little bit in another introduction for me about me. As I told you, I'm from Italy. I'm a member of demo group Resistance. This is a multi-language, multi-region demo group, and I'd like also to suggest, especially for beginners, if you are into coding or into Amiga coding or whatever, there are a lot of demo groups out there, and if you join them, probably there is someone willing to help you in your understanding. So you have extra tools, not only the Phase 101 group or the Fabio Ciucci book. There are also a lot of demo groups up there, and they are very friendly. So this is how I ended up in one of them. You can get in touch me with Discord, with Skype, and I'm also moderator of an Amiga forum. It's an Italian one. It's called Nova Amiga, and it's just a forum, but I'm there also. Can you turn the page, Phase?
Oops,
Thank you. Third page. So this is a non-comprehensive list of my previous works. And as you can see, there are demos, quite stupid demos actually. They are not so well written. My first demo is called the crows. Crow. I don't know how to say in English. It's the bird, the black bird. Mm-hmm. And it was my first demo after reading the Fabio Ciucci book. It featured some, let's say, effects. For example, there is a checkboard. When I was a child, I was intrigued by this checkboard effect that is so common in most of the Amiga demos of the time. And now, thanks to Fabio, I know how to write a checkboard effect. Very nice. The second one, it's just an invitation for a little event here in Italy, and it didn't happen, unfortunately, due to COVID 2020. The third demo is called Rudunia. This is my first appearance at a demo competition, and I ended fourth at this demo competition that takes place in Buenos Aires, Argentina. And this is written, it's a mixed C and assembler for 68,000. And the last one is another demo. It's my first demo released under the label Resistance with my demo group. But however, the code is 100% by me. And it's called No Flight, and it won the latest demo party, Flash Party 2021. And as you can see, I like to release all my code on GitHub free for everyone. So if you are interested how this certain effect works, you can just dig into the code. Please turn the page again.
Ozzy, I'm thinking of showing some of your demos. What do you think?
Oh yes, yeah. Pick one.
Yeah, well, I was thinking of showing them all, but I will switch to the first one. So this is the first one that he did. Okay.
The first one is the crows.
Yeah.
Crows. And it's a little bit repetitive, but it's my favorite one. Yeah, this is the loader. And there is the floppy that is crunching data. It's an MDOS floppy.
You can hear the sound of the floppy.
Yeah, this is just a very basic demo with the dual pair field. Nothing fancy.
I'm just going to switch to the second one. I didn't think it's going to start immediately, but yeah, it started. I started too by mistake. This is the last one. The one that won the Flash Party.
Yeah.
It's 5 minutes, so we can leave it. Nice glitter effect. Nice one. Press escape to return to the OS. So, this one, I started it by mistake before. I'm just going to skip this part. And then I skipped it by mistake. So, here it is. This is the one that came 4th place.
Yes, 4th place.
what he means is that he's not using tables here, okay? They are real-time calculated. Yeah, but the dots, you are calculating them, I assume, no? Yeah. Oh, thank you, Dockster. What? Dockster. Oh my god. Dockster. Dockster, thank you very much. Hello, Dr. Honey. Dockster, don't say oops, okay? Really, thank you, mate. I think it's coming to the end. So I'm jumping back. It stopped actually. So I need to change the page.
Okay, I'm back.
Yes, you're back.
And so I made other stuff. other than demos. And as you probably know, as you can probably tell from the intro logo, I am a vampire fanatic, so I have two Amigas vampirized, and this is why I try to port something to Vampire. So Vampire, for if you don't know what's a Vampire, it's an accelerator card, and it features also an RTG graphics mode. And with this, you can do some more advanced stuff if compared to a regular old stock Amiga. This is why I try to port some very little games with SDL. I try to port it to the Vampire, but they should also work on non-Vampire Amiga if you have, let's say, a high-end Amiga like 4000 with acceleration and so on. These are very, let's say, some video games like Strike, Tuxbook. There is a demo. Of course, this is not by me, it's by MFX, and it works on a V4, also my V2 Vampires. There is an Intellivision emulator called JZ-int-V. I don't know how to pronounce it. If you don't know, in the Intellivision was an old console, very common here in Italy in the 80s. Very strange, with a very strange controller that reminds me some telephone, keyboard, etc. So this is an emulator. There is a V-Control guide. This is an utility to tweak the Vampire settings. There is also an Amiga font editor, that's how I call it, but it does much more, and this is my companion when programming. It's an online web tool, and it allows you to do some stuff like drawing sprites, like let's say debugging registers. You can show bit planes and so on. So maybe in the future I will have a dedicated episode for this. Please,
I'm going to show it because some of the people they already know it. Okay.
Really?
Because I did mention it in my previous game, and I did mention it to others, so I'm just going to show it. So this is the Amiga font editor. It does, of course, Amiga fonts. I think this is how it started. So you can design your own font, okay? Then you can design your own sprite, and you can change even the type of sprite and how big it is. Then you can use it for positioning sprites on the screen, and it gives you the data. You can convert, registers. Use it to get. Sometimes you need to calculate it, and he write a program for this. So this is quite cool, especially when you are a beginner. He also, if you see this, let's say you copy some copy list from RAM, okay, of the Amiga, you can dump it here, and it will convert it into instructions of wait and move. This will calculate the display window start and display window stop for the Amiga, for the screen, which if you've done Fabio book chapter 3, 4, 5, you will need this quite a lot. I think especially 4 and 5. This one It's related to 3D, which I think basically gives you the X, Y, and Z, I assume, of a point, right? And
Yes.
then there are some other things related to trigonometry. You can create your own formulas, and it gives you, let's say, data. And then there is the import an image and converts it into raw. Dockster, I showed you this. um, uh, it's similar to what I had told you. And also, Ozzy did some changes to this recently to for some suggestions that I suggested related to the sprites. Now, if I remember correctly.
Yeah, the attached sprites
Yeah. So
and the
before it could not do attach sprites, and he was gentle enough to do attach sprites. So attach sprites is when on the Amiga you can have a sprite that is 16 colors. So yeah, just back to the screen and next slide. So
yeah,
this,
this is
yeah, continue. Sorry.
this is the main, let's say subject of tonight, the unit testing. And of course, unit testing, I didn't invent unit testing. It's a quite common practice nowadays in software house or in IT industry. And I wondered, why don't we have something similar for the Amiga, even at the very basic stuff? Because I can tell you from my experience, when I wrote all this project, uh, I spent an insane amount of time debugging. Maybe I'm a bad coder, probably yes, but let's say optimization and bugs were very were present everywhere on my project. Let's say if I spend one day adding a new feature or a new demo effect, I spend 5 days debugging because in some situation it doesn't work, or maybe it works on a regular stock Amiga, but it doesn't work on an accelerated Amiga, or it doesn't work if the Amiga has fast RAM, or it doesn't work if the Amiga is the AGA version. So there are a lot of Amigas out there. And what I try to do with this project is just unit testing. So this is a quote from Wikipedia, and unit tests are typically automated tests written and run by software developers to ensure that a section of an application known as the unit meets its design and behaves as intended. The goal of unit testing is to isolate each part of the program and show that the individual parts are correct. So what I was trying to do is, I have my effect, my demo effect, or my feature, or whatever. It's a piece of code. I will feed this piece of code into my scripts, and the scripts will execute it, and they will execute it on different machines, stock Amigas, stock accelerated Amigas, and so on. And the output of this routine must be always the same as I intended originally. This is the goal, let's say. For example, if I draw a line, I want that the memory area interested by the bit plane contains a specific, a very precise data that reflects the drawing of a line. So this is my goal. This is what I'm trying to do. because probably if you write a routine, then you combine with another, and then with another, and then you make a small change, and you have some regressions, and you didn't realize it until you see it fail, your program fail under specific circumstances. So this is why this project exists, and this is the problem that I'm trying to solve. I searched on AmiNet for something similar, and Googling, and it's very weird that I didn't find anything like this. It's also pretty easy to do it. But anyway, I wanted to have my own framework to test my own routines, and just for fun, because of course I'm not doing this for profit or for winning demo compos. That anyway, winning a demo compo doesn't mean you have money. So what I was trying to achieve is just my programs that works fine on all different types of Amiga. For example, I can say try to copy SR data somewhere. Probably it works on a 68, but in the 020 it fails. You have to be probably in some protected mode, in supervisor mode, whatever. So this framework will tell you that you can't do this on a particular architecture. That's it. Can we go to the next page? So this is the AProcessing Director structure, and very straightforward. There is a doc. Of course, this is an ongoing, work in progress, so don't expect the documentation to be up to date with the code. I'm just doing on my free time, especially Saturday mornings. But this is where I'm planning to put some documentation, how to use the routines and how this works. The FS UI unit tester, it's the main important part of this project for me. And what it does, it creates, let's say, a Docker image with FS UI emulator inside, and it runs FS UI in headless mode. This means you don't see the actual window. You won't see anything in the UI. It just executes your code using FS UI and gets the results, and then compares it what is expected, of course. And inside there are scripts currently for A600 with fast and only cheap RAM, and the 1200, I think. This is what I'm testing right now. I'd like to also add vampires here, but it's impossible because FSUI doesn't support vampire cards, and as far as I know, there is no emulator that supports AMMX instructions. So if you want to test your code against a vampire, you have to do on real hardware, as far as I know. Of course, I test my code with FSUI, but also on my real machine. The difference is that I can't, let's say, keep my old hardware, real hardware, turned on 24/7 because it's old and I don't want it. But with the FSUI, you can just set up your server, And every night it builds your routines and it executes under FSUAE and it gives you the results. So every night there is this process, and when you break something, you have an immediate response. Of course, this needs a separate infrastructure. This is just software. I'm not providing hardware to run this test. You have to do it on your own. Lips folder, or as I want to call it, drawer, because drawer is much cooler. It's just where it contains the routines we want to test, and they are categorized by topic. And then there is a test folder, and the test folder has some scripts. I want to start from the bottom of the list just for brevity, because run test Vamos, I don't know if you guys already know what is Vamos or Vamos, I don't know the pronunciation, but it's a CPU emulator. It means that I think it's a Python script, but he can understand the Motorola 68000 code, and he can execute instruction in this Motorola format. This means that you can test the libraries, your routines, also without using the FSUA emulator, so you don't have to set up a virtual machine or whatever. It's just a Python script, and it gives you the results. What is the downside? Of course, Vamos is just a CPU emulator, but Amiga is much more than a single CPU. Okay, it's built around a Motorola CPU, but there are a lot of coprocessors. For example, if you blitz something, Vamos doesn't know what is a blitter, or at least there is some mention in documentation inside the Vamos documentation, but I didn't succeed to work. But anyway, if you have some program, let's say a copper list, the Vamos, I don't think it's able to execute a copper list. So the limitation of Vamos is that it's not a fully Amiga emulator. I just run it for brevity, so you can do a quick check, but this is why it's here. Then we have the Run 68 and Run Vampire scripts, and these are meant to be executed on real hardware. So what I do every time that I want to test on real hardware, I just copy the whole test drawer directory into my Amiga, choose the method you prefer. I use Samba over the network using network shares, but of course you can use not all the floppy disk because they are unreliable and too small to contain all the data. But if you have something like, I don't know, these CF cards, or you can transfer the data and just execute run 68 and it will go through each of the tests. Same stuff for run vampire. This is just for vampire cards. There is a difference. Of course, run vampire won't work on Doc Amigas. This is because inside the routines there is a definition, let's say, that states, okay, we are using the vampire processor and I can use extra instructions that are called AMMX. And this is why the old Motorola won't be able to recognize this instruction and it will crash, of course. And run 68 FSUAE, it's just using for the FSUAE unit tester that I told before. Okay, I think we can go on to the next page.
There you go.
Okay, this is when things are a little bit tricky, and this is an example of how do I write a new test. But for this, I need the live share on Visual Studio Code. I don't know. Let me check if it's. I need the.
So you
the
you want to switch to the server and show the code?
Yes, but right now I'm disconnected.
Yeah. Okay. Yeah, it got disconnected. Don't worry. Okay, I will send you the link.
Okay, let's see if live share works.
Yeah.
Okay.
I give you control. I always have to give you control to be able to do
Yeah, give me control.
following. Yeah, try to move your cursor. Yeah.
It works. And the terminal?
Can you access the terminal? No?
Yes. No. Cannot edit or read only terminal.
Okay, so I'll add the terminal. Live share terminal. Redirect. See if you can access it. I'm not sure if I clicked the right thing.
Yes,
Yeah?
you got it. Okay, so let's write a new test. We want to test the point routine. The routine plots a point in a given XY position inside a bit plane.
Can we show the directory structure that you have? Because you discussed it in the slide, but I think they need to see it. It makes sense to see it in the for real, you know.
Okay.
So basically we are. Yeah, sorry.
Are they seeing my window, my VS Code window?
No, I was going to tell you to show it on your on the terminal because if I show it there, it's hidden. You know, there's your camera. So.
Okay. Are they seeing my terminal?
Yes, they are.
Okay, so it's just what I discussed before. There is this doc. The build is created by the framework, so we don't use it. These are just notes here and the README markdown file. FS unit tester. This is why the copy. It doesn't copy. Okay. F8 user tester. As you can see, it's nothing, not rocket science. Just a couple of launch tests, A6600 fast.
So do you mind if I explain something?
Yeah, just if we want some more in depth of how it works.
No, what I was going to say is we are used to using the Amiga and assemble towards the Amiga or using WinUAE and see the results on the screen. This approach is a bit different. So you need to use a bit of your imagination in a way if you're not used to, if you do not know what unit testing is. So basically, let's say he has an image with a line, okay? And he runs a plot routine, and then he compares the pixel by pixel, let's say that, not to go into detail, and they must match to that image that he has in the test, that he has created as a test. So basically, that's how he knows that the routine produced the correct output. This is, in a way, the modern way of approaching things, let's put it this way. But if you are not used to developing using unit testing, you might struggle. I just wanted to add that, just to try to give you a bit more info and to start imagining what he's doing. He has a couple of routines that he runs them, and then they test against something. That's what he's doing. Okay?
Yeah, let's just make an example so
Yeah.
probably they can understand better. Let's say I plot a point on coordinate 0, 0. It means x is 0 and y is 0. So if you followed the previous streams of phase, you know that in computer graphics in general, and also on the Amiga, the y-axis is inverted. So when you increase y, you go down. And when you decrease y, you go up. This means that 0, 0 is the top left point of the bit plane. So, since the whole framework works with bit planes, so planar mode, it's not the chunky mode are not supported right now. I'm planning to do in the future, maybe, I don't know. But since we are in planar mode, plotting a point on the top left, it means setting the first byte to the value of 80. And I think this is trivial, at least for me. I don't know if about the level of your audience, but of course you have to think in bits. So you are turning the first bit on. So 8 is the most significant bit of the first byte of the bit plane. So my framework just checks if the first byte is 80, and then of course it compares all the other bytes inside the bit plane, and they must be 0. This is what we are doing. But right now, I sorry if I'm making some confusion. I wanted to say something about this file, how FSUIE is run on the background, because this is something that okay, it's in the README file, but it's worth to mention, because probably you know that for Amiga the OS and the Kickstart is not free. It's proprietary software. I think it's owned by, I don't know, Cloanto, I don't know. But the thing is, I can't include the Kickstart in my repository. This would result in a copyright violation. So what you can do here, you have to specify a directory inside this YAML file where the Kickstart is provided. Otherwise, FSUIE won't run anything, because the Kickstart is so essential part of the Amiga OS that without the Kickstart, nothing works. So this is why you have to provide your own files and part of the operating system, but it's inside the instructions. And of course, if you are in trouble setting your environment, I'm available for further explanation or give help, at least. Okay, this is FS UA unit tester. Let's say. Okay. Libs, this is my libraries that I want to check. You can see there are, let's say the most interesting part is here rasterizers, just drawing routine like a triangle 3D, line, etc. Most of them are derived, copied, or derived, say, my adaptation from the Fabio Ciucci's book. Other routines are done by me, completely by me. Okay, let's go back to the directory, tests, and this is cd tests, and these are the tests. As you can see, there are drawing test, filling test, matrix test, etc. What we want to test is the point routine. So the point routine is copied from the book, from Ramjan book. It's very simple routines. This is why I picked this for this episode. So let's go into points. CD. Oh, but I can just use the right one. Points. Well, test, drawing test, because it's a drawing test. Points. Drawing test point dot s. So these are my tests. For example, the first test works like this. This is a macro. I love macros because they save some time, because you don't have to put things in the stack and perform RTS to return to the previous context. But anyway, what this test does, it clears the bit planes, it resets the transformation matrix, and I will talk about this maybe in the future, not today, but just if you don't know what is a transformation matrix, let's say it's just a series of numbers that describes the setup of the plane. So this is the default one, it's reset, and now we are going into the center of the screen. So for example, all my tests are on PAL low-res mode, which in Amiga is 320 pixel wide and 256 height. So if you divide it by 2, the x and the maximum x and maximum y, you get this coordinate, and this is where I'm positioning. Then I do some rotation, this is useless, and then this is plotting 3 points. It's plotting a triangle. The first one will be at this position -5, and so on. But I want to do a simpler test. And what we can do is, let's say, add a new test. So, for example, let's copy. Let's say if it works. Drawing fast. Okay, this is the label, because as you probably know, labels are just addresses in memory, and the framework will jump at this address when it will execute the test. it will clear the bit planes and do all the other stuff, and then we will plot a point at position 0, 0, and this is the color. We are telling that we want to change only the first bit plane, so color 1 will be displayed. And this is the actual routine, and here are just returning the bit plane address back to the framework. Then we need to tell our GCC, because the framework is built around GCC, the X definition in order to properly link, and we save the file. So now we open the C file and we just add the test like this, for example. Copy. Test ID equal 4. We say this is a description, so point 0, 0. We just say please execute the drawing test 4, and this is very important. We are telling the framework to check the first 2-bit planes. So first bit plane must be all zeros except the first bit. The second one will be all zeros. And we save. And that's it. Now we are ready to run the test, and let's see if it works. And if it don't, doesn't matter. We open.
Are you in the console?
Yes, I am inside the console.
I need to open the window. Okay, because I had full screen. Okay, no worry, continue.
Docker okay, I'm entering the
the
container because Docker exec.
When you switch between the text and the console, just tell me, just in case, because sometimes the window closes, so I have to open it again.
Okay, now I am on the terminal.
Yeah.
I must go into the same directory and just make. Oh, I forgot. I have to go back here in the editor just to inform, add the prototype. Okay, and now back to the terminal. And just run make. And just run make test. And it doesn't work, of course. Make file test error. I don't know why.
Error 1.
Make file 10 test error. It should execute this. I think there's nothing wrong here. I don't know. This thing are always expected in lives. Make clean, make test. I don't know. Oh, anyway, I will see it later why it doesn't work. It's just telling me that make file 10 it doesn't work. But anyway.
But the other tests worked. So the other tests that you had before it, they worked.
Yeah. Oh yes, it's look. Go back into the editor and you see why. The indentation.
Oh yeah, definitely. Yes.
Indentation is a problem in assembler. You have to put the labels at the start of the line and then put something on the instruction like tab or spaces. Okay, so go back to the terminal and just make test.
Wait, I need to open the terminal.
Okay, I will do it again. Tell me when you are ready.
Yeah, it's done. Okay.
Okay, you just compile. As you can see, I am using the GCC for the compiling and linking, and this is a very powerful, let's say, assembler. It's called the VASM, and probably you already know, and this is very good because it supports a lot of different CPUs. So the assembler part is assembled with the VASM, and the other is just a regular GCC. Now, if you run make test, it's telling you that okay, the expected file is missing, and this is the result. I don't know why the terminal is showing me only part of the screen, but as you can see, this is the bit plane 1. Bit plane starts from 0, so this is the second bit plane.
You want me to scroll up?
Can you see it?
You want me to scroll? I can scroll up if you want.
Okay.
So this is bit plane 1, then there is bit plane 0.
Yeah, go to bit plane 0.
Yeah, and you can see that there is the pixel. I mean, 80 is bit 1, okay? Sorry, bit 7 from the, so it's the, you know, the one at Y 0 X 0, basically.
Yeah, and this is what we want. We want the first byte to be a hexadecimal 80. This is the expected result. Of course, this is a very stupid test, and it doesn't make sense to write.
Yeah, continue, sorry.
I just want to say that this is just for showing what how the framework works, because in real life you do some much complex tests, of course, but just to get the idea that now you have a representation of the bit planes in your terminal. Now, now that there is a file that has been created, it's called output4.bin. And
I'm going to scroll down so you can continue. Okay.
Okay. This file stores the results of the bit plane, and now usually what I do at this stage, I check the new file, the output4 file. I see that there is hexadecimal 80 at the top. Okay, looks good. Then I move this file. Can you see when I type on the screen on the terminal?
Yes.
I do this. Since this is the expected output, I move this into the expected folder, and this is the name of the file is misleading, but it's tweakable, it's configurable, but for now let's use this. And then now it means that every time the framework will run the point routine, it will check 00, and it will check if the first byte is 80 hexadecimal, and if it does, okay, all tests are okay. If there is at least one bit different, it will warn you and say, oh, you made something stupid, please correct your framework, your routine, and so on. So you can just test it again, and then see all tests okay. We are informing that there are 4 tests inside this folder, and all tests succeeded. And that's it, I will say. I will go back to the editor just to strip the verbose equal 3 because I don't want to be verbose anymore. We will see just a nice message that the test succeeded. Okay. Now I'm going to the next page, and the title is "Let's Break Things."
So you want to go to the slide again?
Yes.
Okay. So. Okay.
We will
So I have this first. Are you seeing my screen?
Yes.
Yeah.
This one, this is what we just did.
Okay. So then this one.
Let's break things. Exactly. So in this part, I want to break things. Now that we know that the desired output after plotting at point 0, 0, let's break things. Let's assume we make a mistake when trying to add a feature and or optimize the point routine. Open the file. Okay, we are introducing a bug. This is intentional, just to show that the framework will complain about something. Okay, let's go back to the editor. Can I go?
Yeah.
Okay, the routines are inside here, and libs folder, rasterizer.
Yeah, you can continue now from here.
Yes, I'm continuing. I'm inside the editor.
Oh, yeah. Okay, continue. I didn't see you, that's why.
Okay, now we must find where the plot point routine is defined. I think this is the one point semicolon. Okay. So, for example, this is a very stupid mistake that I keep doing because in the Motorola processor has two very similar instructions. One is not and one is neg. And I keep confusing them, switching. The not, it's a bitwise operation. It just flips all the bits in the register. And the neg is complement.
Yeah.
So let's say that we say neg b. So this is a bug, an intentional bug. And now I'm going to the terminal again. And I run make. And of course the compiling succeeds because neg is a legit instruction. And then I say make test, and as you can see, the framework will complain that something was broken. We have regressions because it expected 8-0, but in memory there is 0-0 and the bytes are 0-0, etc., etc. So that's the point of my presentation. This can prevent you to do stupid things. I don't know if I got to the point, if it's clear or not.
Well, I think you explain it with points on the screen. Sorry, on a bit plane. Normally we see them on the screen, but instead we were plotting in a file and then changing against, checking against another file that we have the same output.
Yeah.
Now, can we skip? Can we go to the Amiga and show the demo?
Yeah.
Yeah.
I just want, if I have time, I
Yeah.
just want to add just a little thing
Yeah.
and say why do I prefer to check things comparing files? Because the main part is that if you compare file, you know what's wrong and where it's wrong. If you plot a point, let's say outside so in a real demo, outside the bit plane data, maybe you are changing a bit on the code on a hunk that is meant to be code, and the program crashes. You have no information, no clue why the Amiga crashes, and you are left with your debugger, and you have to test why in this particular scenario the Amiga. So what I usually do first, I test it with my files. Expect all the results are okay. Then I move to the next stage when my routine is tested, and I'm pretty sure that the point will be plotted inside the bit plane. This is just an example, but my experience told me that maybe you can think this is a useless operation. You are wasting time testing things. Probably yes. Probably I need it because I write code. Yes, totally right. But it will save you. For me, this saved me an incredible amount of time debugging with FSUIE, and you doing a step-by-step instruction and catch the particular frames that is glitching or it's not working as expected. With this method, I also spotted a bug that for me is a bug inside the RamJam code. And so for me, it's my method of work, and I'm not stating that my method is best than yours or the other debuggers out there. There are great tools, of course, but this is how I work, how I like to work and go into, let's say, production. So into writing demo only where the code is tested.
Mm-hmm.
That's
So
it.
a few points from what he said for those that also follow me. One, notice that he constantly mentions the book. The book is key to the book has got several routines that we have discussed and I have shown, but they are the basic to expand. So this is a key point. The second point is that think out of the box. There is, as you can see, he has a different way of debugging his own code. When I first saw his code, I also was saying, "Oh, why all this?" But then I got it, and I really understood why it is so powerful the way he does it. As he said, if you are plotting and you plot outside the screen and it goes somewhere else in memory, most of the time the Amiga crashes. Okay? It's very difficult to catch those type of bugs. And with this method, you will know when such a thing happens. In a
Uh,
way, it takes away your imagination doing this because normally we are used to see it on the screen. But once you get, the picture of it and you start imagining it in your head, then you don't need the screen anymore. So yeah, it's a different concept, but it helps a lot. And he is faster writing code than probably many others out there using this method. So, having said that, I go.
Can I mention one final thing, but
Yeah, yeah,
then
sure, sure, sure,
I
sure.
will shut up for
No,
good.
no, 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 no. Come, continue.
Uh, of course, this is not bulletproof. I mean, if there is a bug inside my point.s routine, it doesn't mean uh, that the framework will catch the bug. I want to say just if you do a lot of tests, there is a bigger chance that the bug will appear and you have the chance to fix it. Because, of course, if you write just one test, you are just testing plotting into 0x and 0y works. It's trivial and it will work. But try to run 100 tests, 200, 1 million tests. The more tests you have, the more you will be bug free. I don't know, but you are going toward the right direction. This is why all the tests, there are a lot of tests here, about 100, testing all my routines. And it takes a lot, but I don't care because it happens during the night. So when I sleep, and when I wake up, I have my results and they say, oh, this routine you changed last time broke something in this particular scenario. So I will not merge the code into my demo. I will go back to the unit testing and try to spot the bug. But as I said, this is a helper. It's not, it will not prevent you to write bad code or bad routines.
Yeah, exactly. Okay. So, shall I go to the Amiga and show the demo?
Yes, this is not really a demo. It's just
Yeah, yeah, yeah.
yes, it's a demo. It's a demonstration of these routines after they have been tested, how they behave.
As you can see, these are all using his routines, the plot routines that we have used or we have seen in his framework to achieve such result. Of course, he does more complex things, but right now he doesn't want to show them to us because he is going to participate in another demo and he doesn't want a demo contest and he doesn't want us to see that. Right, Ozzy?
They are not much more complicated than what you are seeing right now. I like old school, very simple stuff.
Hello, Pants. So also for those that has done the book, notice that the copper effect behind is also from the book.
It is.
Yeah. So you know how to do the background already, okay? And you know how to plot lines and you know how to do pixels. So
Yeah, what I usually do is just take some random, let's say, example from the book, rip out the game loop routine and replace with my routines. And this is the result.
yeah,
I use the startup sequence from RunGem, and I must say that all
the
the
best one.
examples in the book are let's say almost perfect. So it's very mature code. It's very unlikely that you will find some bugs inside their routines. They have been tested over the years, I think, and they are ready for production, I would say.
Yeah.
This is just some routines that test the rotation along the z-axis, the y-axis in 3D, and in the background there is a copper list from RunGem. And that's it, I would say. I think we are at the end of the slide.
Yeah, probably.
Yeah. So I would say I'm done.
Yeah, actually it says face, please run the file, I'll compress. So yeah.
Sorry if this took too long.
So I can tell you, so today it was a pilot. To be honest, this was a pilot test because of the setup that we needed to use to run this type of, let's say, tests. However, Ozzy is kind enough to be joining me in future series, okay, in future episodes, where he will be explaining demo routines and showing demo routines. So there will be me coding the game, but there will also be Ozzy doing demo code. I mean, using his framework basically, and we can see results of that later on. Am I correct, or have I missed something, Ozzy? Or I am?
No. Right now, I didn't prepare anything, but
No.
I can show something the next time we see.
Yeah, exactly. Also, I am going to be away, so there is no book series this weekend, not even the one after. And of course, when I come back, I will start preparing with Ozzy for the next episode. It will be divided into, as I said, there will be the game and there will be demo. So it's a mixture of both. Also, like that, people can switch from one to the other, because I think it can become more interesting. Several people has asked me about demos, and I think this is a good way of combining things together. I mean, I like more doing games. Ozzy likes more doing demos. So there you go. You have both things. But the common factor between me and Ozzy is the book. Okay.
Yeah, the
Follow the
RunGem
book. Follow the book, and everything else will come up. Okay, everything else will follow. We can do so right now I haven't really, I started the intro series and I started the game series, but I think I'm going to merge them and having the same on the same episode we will have part demo, part game, so that let's say it will be more interesting. Let's put it this way. So there will be the part that Ozzy will do, and then there will be the part that I will do. Also, Ozzy cannot. I mean, today he was kind enough to join me from the beginning, but normally he will not be able to join me from the beginning. So obviously there is going to be the first part will be the game part, and then there will be the demo part. So yeah, and now while we still have the Ozzy's demos on the screen, I am going to switch a bit to the game and talk a bit about the game jam. So let me find it. and switch to it. So you all know that this week I launched the Game Jam to do the Google, to bring Google to the Amiga or to the 8 or 16-bit machines. Basically, I want the T-Rex of Google. It's open source. You're going to struggle to convert the graphics if you take the Google graphics, because they are very big, to bring them to the Amiga, Commodore 64 or whatever. However, it's cool to bring such a game to the retro machines. I gave some links here related from where you can start to get an idea. Okay. However, I did today, okay, just before, actually not today, yesterday, after I finished the other stream that yesterday I was guest on another stream. After I finished that stream, I started the code for, if I can show it, given that it's still there and it's not, so I need to open it. So I do have the framework, let's say, not framework, but I'll tell you what I did. I was going to explain it in the beginning. No, I need to do the gem first. Definitely the gem. It was my my idea in RPI, and I have to, keep my promise. But what I did, I took all the routines that I used in Mr. Pooh, okay? My famous game, Mr. Pooh, that I did not expect it to be famous, to become famous. Let's put it this way. And I am starting to build the game using those routines. So, yes, this is my new stream series. It will be divided into two. First half, it will be the game. Second half will be demos. So first part, it will be me. Second part will be Ozzy. Because I took the framework of Mr. Pooh, there are lots of routines that are ready. What I don't have ready is the graphics. Okay. So the Amiga series Mr. Pooh took about 16, 17 episodes. This should not take us that much. It will take a lot less because the routines are there and I will just be merging stuff. But also this shows how, because that was our aim, to build a framework of routines that we can use in other games. It will be every Friday. So the game, okay, as I said, if you notice, I have all here on the right side, I have all the routines except the data. I have the files, but the data is empty. So the game shouldn't take me that much to do, at least I hope. Because the routines are there. It's more converting the graphics. I will try to use same graphics like Google has, and the reason why is my aim is to really have that game on the 8-bit or 16-bit machine. I can do different. There are different ideas, but the T-Rex needs to be that. Because it's open source, you can do it. It will be my own graphics, but that game, because I want to show that, hey, a browser or an x86 machine, you know, is no special compared to our 8 or 16-bit machine. No, you don't have to do the T-Rex. I am going to do the T-Rex. It's my challenge, let's say, to bring the actual Google game as it is or as it looks to the machine. No, you can do your own. No, I was talking about myself. I want to create same thing as there is for Google, as what Google have. Of course, probably then I will change it, but initially I want same type of thing, just for a laugh. That is all. It's my way of saying, hey, an 8-bit machine or 16-bit machine can do the same what you can do. That's all. um, yeah. You can use, as long as it's 8 or 16-bit, you can use whatever you want. It has to be an 8-bit or 16-bit machine. It cannot be x86 and it cannot be a Raspberry Pi because it's not 8 or 16-bit machine. That's it. But any retro machine. Yes, exactly. Um, some people consider DOS as retro, which I do, but unfortunately, with DOS, people try to. I mean, I had this in the past. People try to be cheeky on DOS, so you do not know if they really created the game themselves or things like that. And I do not want to be going and asking for code, or because not everybody wants to share his code. Maybe I do not want that. So that's why eliminate x86. Yeah, you can do that afterwards. Why not? But you can do it for the BBC also, whatever, whichever machine you like. I mean, I don't mind the BBC. Or you can do it for Atari or ST or Amiga, whatever. Anyway, so that's where I am with the game. I have most of the stuff. I just need to organize and start adding the data. And then after I add the data, I should just be joining the routines. And there are some routines that I need to write, like the jump routine. But, the scroll, I already have it. It's in the intro that we did, Dockster. The intro of the scroll is the same. I'm going to use the same scroll routine using the blitter to do the scroll of the thing. So there you go. I even imported, for example, this is not in the game. It's not in the game, but I have created my own. But of course, then it calls the what we learned in the book, my own fade in, fade out routines. So that when I create certain effects in the game. But yeah. I have other routines like a spiral routine, but not like what Chalan did, but more like Turrican, to jump from one thing to another and things like that. But it's me, and what I was doing. So that's basically it. I thank Ozzy for his time today. Actually, it was a cool thing. So, guys, I'd like to thank Ozzy once again.